Yeah, everyone's really feeling it now. So we're gonna wait for the Perseverance rover image of us.
And that's its shadow, right, Taryn?
Yes, that's a shadow. So the onboard navigation camera points straight down, so we're seeing its shadow.
That Ingenuity has performed its first flight of a powered aircraft from another planet.
Oh, wow! China Sea Space Mars Simulation Base in the Gobi Desert. That's some amazing stuff. Its aim is to educate and provide an environment for youth and tourists to experience life on Mars. I love Mars. Oh, look what they built. And it even got a mosque. That looks awesome. Oh wow, they even created a tiny crater. Amazing stuff here. Is this a Mars car? How do you get all those materials here? This is Mars. Oh, look, this tiny Chinese guy in his tiny spacesuit. That's so kind. Oh, look. They even got a Mars rover. Some cool stuff we see here. Who built that? The Martians? Oh, that looks nice. Spacesuits. Yeah, it has some reality. Oh look, they even have a lunar lander on Mars. Do you see what I see? It looks like there are two suns on Mars. Hey, you see that, guys? My shadow points in a different direction. I think they have multiple suns on Mars. That shadow not really match. Oh well. It doesn't matter, it's just a simulation. Let's have a look at some sun directions on Mars. And I will use NASA's own Mars 24 Sun Clock application. With this application you can fill in the latitude and longitude. And then set the time on the time you want. And then it gives you the directions of the sun and the elevation and the local Mars time, the current local Mars time, I must say. Let's model up two locations and see where the sun is on Mars. We are here on Mars's equator, on the prime meridian, and this is the data from May 6. Current local Mars time, Earth time, azimuth and elevation. So let's model up this azimuth. .8 with an elevation of 34.3. Then 34.3. Let's do the second one. On the prime meridian, 85th latitude north. Same data, same time, everything same, except the latitude, of course. The azimuth is 124.6. Elevation 19.4. Let's see where the sun is. This is total trash, NASA. And you cannot call this a triangulation because there is a lot of space between the lines where they cross. And we need to make those lines a couple of 100 million kilometers long, and the angles become wider and wider, of course. I love Mars 24 sun clock because for me it's very important to know the time on Mars. Oh, one Mars rotation is 24 hours and 39 minutes and 35 seconds. So that means a 180-degree rotation takes up about 12 hours and 20 minutes, a little less. So if one rotation takes 24 hours and 39 minutes, it would be logic. It is 12 hours and about 19 minutes later on the opposite side. Yeah, that would be logic. And it would be logic. We have 4 slices of 90 degrees from about 6 hours and 9 minutes per slice. But on Mars it seems to work different. I selected 4 locations. It is the Mars prime meridian on the equator, 270 degrees east on the equator, 180 degrees east on the equator, and 90 degrees east on the equator. And I selected this time, and it's on all 4 screenshots the same, and then it gives us the current time on Mars. As we can see, the current time is 21:39 Earth time, and then the Mars time say 18:41. That's the local time. So, and then I can go to the opposite side, 180 degrees, and then we can see it's 12 hours later. Exact 12 hours later. 180 degrees opposite should always give a 12 hour and around 90 minutes difference. What an idiot. We can clearly see those are parts of 6 hours. Only this one is a minute longer. So where is this 40 minutes? Maybe we have to jump to the next day on the prime meridian and see what happened. We see here an azimuth of 270 and a sun elevation of 0.1. Let's go to this close as possible on the next day. Here we are on the next day in the prime meridian, and here the azimuth is 270.3 and the elevation is 0. So that's practically the same azimuth and elevation. It shows me a time of 22:18. So let's add up 29:39 UT time on the prime meridian here and 22:18 UTC time the next day. The result, 1 day, 0 hour and 39 minutes. This is how they do it. They just add about 39 minutes to the next day. So dumb asses. You would never expect somebody opened 4 windows on your app and look at 4 different places at the same moment. Yeah, only some idiot from Amsterdam do that. So you show us times on Mars. What do you use yourself? Bullshit. Please send queries and bug reports about Mars 24 to Dr. Robert B. Schmuck. Yeah, already reported a bug, but you put this bug in on purpose. If I want to set a custom time, and I just put something here, then it don't work. It got stuck on 1970. So I have to adjust the time and date on my computer. And then it works. But it cost me a lot of time. Pieces of shit. Ass clowns. Do you have something more for me? I feel a little bit boring. Let me see. Wow. This is some cool application. Tracking satellites live that orbit Mars. Yeah, now that's correct. That's my time. That's UTC plus 2 hours. 9:48. Let's check the Mars clock. On the prime meridian and the 90 latitude north. This is UT time, so that's correct. It's minus 2 hours for my time. Let's have a look at this top view on this moment. I see the day and night side being different. And both are live on the same moment. Which one is the real one? Jesus Christ. So we can see the poles are oriented in the same way, with all these ice mass pointing in the same directions. Only the night and day sides are not similar. So your tiny program is called Mars Now. But this is also Mars Now. I'm going to leave it here. That was enough bullshit in one video. And maybe I do a part 3 on this Mars planet. Peace. Pieces of shit. Pieces of shit.
Slightly oriented maledictory right there. I don't know who did that.